Let me give some stuff back. Abriel is not here. Berkeley is here. Abel is not here. Ivana is here. I don't know where we find this, to be honest. I'll keep looking, but if I don't find it, I'll give you the benefit of the doubt. Okay. Oh, the numbers are going up. Yes. Yes, go for it. Welcome. Where are we at?
This really quick, this just when you reflect across the x-axis, is it kind of like just mirroring?
Yeah, let's do a quick example. Shit. So if I have negative square root of x, the base function would be this. And then I literally just take all the outputs and make the opposite sign of what they used to be. So negative 0 is still 0, negative 1 is negative 1, negative 2 is negative 2, and then it looks like that. So this is the mirror in that case, yeah. If I put the negative on the inside, the mirror would be the y-axis. Why does that make sense? Outside is up and down. You all agree with me that just flipped from up to down? Inside is left to right. So there's a negative on the inside, it would flip this way. Let that make a scary amount of sense. It's consistent, it makes dots. Okay. Maybe.
So the negative is in the inside, how would that?
So if I had the negative on the inside, the base function would still be Scheisse back. Bam. Bam, and then what it does is 1 used to go to 1, now negative 1 goes to 1. Now negative 4 goes to 2. So this would be the base function, this would be the new shifted function. Is that cool? And again, I really want this to make sense because I used to have to put a 1 in to get a 1 out. Now I have to put a negative 1 in to get negative 1, 1, to get square root of 1 is 1. So it's inside, it's a reflection because it's a negative, and it's a left-right reflection because it's inside with the x, and x is left and right. Kick ass. Kick all of the ass. Okay. How you guys doing? I'm sorry, I laugh at you a lot, but the expressions are always neat to me. Yes? Oh, sure. It has like all the transformations. Jalapeno. Here, let me do more with the square root, and then because your question isn't about the absolute value function, you're cool with it. It's about the transformations, right? So, so how many transformations are happening? 3. Good. What are they? In what order should I do them? Left 2. Flip over the what?
The graph.
X-axis, up and down. Good. You can even say up and down flip if you want. It's outside, so it's going to be up and down. So this is flip over the x-axis. Down 1. So then I graph the base function. So 2 things. You have to know the shape of the function, and you have to know some anchor points, some base points. When I see your work, if I don't see the base function, and you don't list the transform, that's bad, that's everything's bad. I need you to list the transformations, graph the base function, So at least I get an idea that you are actually applying the transformations. Are you guys? Never plug shit into the function they give you. That's not the point. We're trying to go past making XY tables all the time. We're trying to get past that. Okay, maybe. So now I just take a point and I start doing this stuff to it. So if I took this point, I would go left 2, flip over the x-axis, and then down 1. That's what this point did. Left 2, flip over the x-axis, and then down 1. Is that cool? And if you need to, you could do several graphs doing one thing at a time. Not a damn thing wrong with that. Take this point, left 2, flip over the x-axis, down 1. This point, left 2. If I flip over the x-axis, I go nowhere, down 1. It's going to have the same shape, it's just going to be reflected and moved back, so it's going to look like this. Whee. Anybody have a way I can check that besides graphing it in my calculator? Yeah, what's this point here?
-1, -2.
-1, -2. When I plug a -1 in, -1 plus 2 is 1, square root of 1 is 1, -1 minus 1 is -2. When I plugged in -1 in, I got a -2 out. It always feels good to realize, oh shit, I can check this. Okay, maybe. Yes?
From homework, I formed number 51.
Thank you. Hi. Let's see, 51. Blah, 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 blah. Oh, okay. So this one? Is it this one?
Yes.
Oh. Did you graph all 3 of these and just see?
I stuck on the one of the 3.
Oh, what happened when you did this? So this looks like this.
Yes.
What did this look like? Do you remember? Let's try it. Arg. Sorry. I don't know why this calculator does that. So this was 1, oh, I'm sorry, it was x squared, is that right? Was it x squared? Yes. And then this was 1/3 x squared. So in blue is the, oh shit, let me hit zoom, stop it. Zoom 6. Okay, so in blue is the original, and in red is the transformed one. What happened?
I have to go wider.
Yeah, you can answer 2 ways. Either it smushed down or it widened out. Both of those I would accept.
But doesn't go by 3.
Huh?
Doesn't go by 3.
What do you mean doesn't go by 3?
So if we take the points in with
Real quick, you ready? Where is the 1/3 in?
within the x.
Is it?
That's
Is it?
It's multiplied.
Is the 1/3 inside with the x?
That's nice.
That would be parentheses 1/3 x, all of it squared. Then it would be inside. I really want you to show. Here is if it was inside. This is what it would look like. That's in with the x. This is outside, yes? Do you guys see that?
Don't you do the opposite since it's dividing with
No. No. Again, when do you do the opposite?
But it's inside the x.
When it's inside with the x. This is outside. Okay, and I don't blame you. I don't blame you. Some of this is not, well, let's be honest, Jeff. A lot of this is not intuitive. Until you remember, you have to remind yourself. When it's inside, if it was this, all my x's have to be 3 times bigger than they used to be. Because the first thing it does is take 1/3 of it. Is that cool? So if I used to put 1 in to get 1, I now have to put 3 in to get 1. So that would pull it this way. Yes? Here, it takes all the outputs and just straight up cuts them in thirds. So it just smushes it. Okay. which is exactly what you see when you graph.
That's what I said, yes.
Okay. I don't blame you. I understand you could very easily think that's with the x because your brain says, look, human, it's right next to the x. But if it was going to be inside with the x, that would be inside with the x. They're both being squared, so they're both inside. Okay. That's a good question. I love it. Okay. Anything else from homework stuff? Yes.
Number 15 for 3.7.
Hi. Oh yeah, good. X squared minus 5. Why is that not invertible as it stands? X squared minus 5. Why is that not? Why does that not have an inverse?
You have to square root it if you did.
Even more directly, if you graphed it, what would it not pass?
The horizontal line test.
Yeah, it doesn't pass the horizontal line test. So this is such a cool little idea, and it's going to come up in a big way later this semester. But here's the idea. This feels so weird to us, but we are the humans in this situation. If I have x squared, what was it, minus 5? It almost doesn't matter, Jeff. So if I have x squared minus 5, it looks basically like this, just to plop it down. Does that pass the horizontal line test?
Yeah.
No. A horizontal line goes through more than once. There's at least one horizontal line. There's an infinite number of them. You guys with me? That's the horizontal line test. We're the humans here. Where the shit did x squared minus 5 come from? Somebody made that shit up. Somebody just thought it up, or maybe it's if I want to make this 1-to-1, I can alter things. I can say, let's not use these numbers. Can somebody tell me, how can I make this become 1-to-1? Why is it not 1-to-1? Because when I start to draw a horizontal line, it hits the line and then it hits it again. If you were the math god and you could reach down with your giant math god eraser, what would you erase so that this would become 1-to-1, so that a horizontal line would only go through once? You actually have two options.
Either the left side or the right side.
Yeah, you would just erase this. Very often we erase the negatives because we want to keep the positives, but it doesn't really matter. If I erase this whole side, is the result 1-to-1 now? I'm the one trying to make this. Jeff! You just said you were going to erase it. All right, I know. Be quiet. Jeff. Oh, yeah. So I erased this side. Does that pass the horizontal line test?
Yes.
Totally. Totally.
How would that look an equation from?
Sorry?
How would that look an equation from them?
No, it would look the same. The equation for this is y equals x squared minus 5, but next to it, it would say x greater than equal to 0. So what's the inverse?
So it would be,
You would switch the x and y. Now here's the big thing. A lot of you guys got the domain correct, but when you solve the inverse, you still put plus or minus. Why do I not need to?
because it's not plus or minus.
Because it isn't plus or minus. Okay, so when I solve this, how do I solve this for y?
X plus 5 equals y.
Plus 5.
Square root y. Square.
Square root. Now, I do not put plus or minus because we've already chosen the positive side. We already chose the positive side. Maybe. So real quick, visually, what point is this? No, come on.
Oh, 0 negative.
Yes. So the inverse would go through what point? Here, I'll give it away. What point would the inverse go through? Come on, you can do it. What do you do to find the inverse? It would go through negative 5, 0. And then this goes through, it almost doesn't matter. It would look like this. Yes? That's horribly done. That's really bad. It should be reflecting around here, but I'll be okay. I don't know if you guys are really with me. It should be more like that. I'll be okay. So isn't that what's true about the y's here? What's true about the value of y everywhere on this graph? It's positive. That's why we have the positive one, not the negative one. We chopped half of the function off. So when I solve, I normally would get plus or minus. But again, what did we do? We chopped half the damn thing off. I need you to see. Visually, if I cut half of the damn thing off, it passes the horizontal line test. Computationally, if I cut half the damn thing off, I don't have to put plus or minus. And the plus or minus is what would tell us, oh shit, there's no inverse. Because there would be two outputs, yes? But since I cut half the damn thing off, I don't put the plus or minus. I already chose the positive side. Okay, maybe. Maybe? You self-check? God, I wish it made sense. That would be so awesome if you did. Alright. Do you guys... Okay. So you need to start realizing there are things that make sense about math. It's not just a bunch of, let me take what this guy tells me and give it back to him so it gives me, no, that's bullshit. It has to make sense, and if it doesn't, that's when you come see me or you ask questions. So you got two ways to look at this. We had to chop it in half, we had to cut half of it off to make it invertible. That's why here I can cut half of it off, because we did. I don't need the negative half. In fact, I wouldn't get the negative half. Okay, alright, I'll let that one sit there. What gets really intriguing for you, hopefully, is if I do have a function that's not invertible, we now see a way to make it invertible. I just restrict it. I just chop some of it off. We're going to see that happen later this semester. Okay. Anything else before I answer my own questions I'm keeping track of here? You guys all right? Anything else? Okay. So, I got a couple things I want to remind myself about. I'm going to talk more about end behavior in a minute, but I want to show you how to find the min and max on a calculator. Is anyone curious about that? A little bit? Okay. Okay, let's do a problem related to a problem from the homework. Let's see how this works out, Joe. I'm curious now. Let me make something up. Bless you, I think. Make sure it's gonna do what I want it to. Oh, sure, that'll work. Okay. So let me come back, I'm sorry. So if you have a calculator, go ahead and put this into it. If you don't have a calculator, you're fine. Just sit and watch, or watch it later. So bear with me, x minus x to the fourth plus x squared. And if you plug that in, and you hit zoom 6, you should get the same graph that I get here. Zoom 6 is a really good place to start. Does everybody see a maximum? Yeah. Can we see what it is really well? No. So if I had to guess at it, like estimate it, I'd love to like get in close to it so you can see what the shit's going on. But I'm going to do you one better. We're going to do that first. Everything's happening right here. Does everybody agree? Yeah. This shit just goes down forever, so that doesn't tell me anything. So I'd love to freaking enhance, like CSI. Enhance. Okay. So here's how I do that. This is one of my favorite things. And of course I would have a favorite thing about a TI calculator. If you hit zoom, the very first one. I can't remember if I used this with you guys yet. But if you ever hit zoom and you wonder, what the shit is Z-Box? Dragon Ball Z-Box. No. If I hit 1, it seems like nothing happened. But here, just watch. See the cursor? The cursor will be one corner of a box. So if I hit enter, I can then go down and over, and I've identified an area for it to zoom in on. Enter. Ooh, okay. This thing costs enough money, yes? Now, if I needed to, I could estimate that. I could trace it, but we could do better. Do you see right here it says calc? Everything up on the top row is graphical, obviously. So calc must be somehow graphically calculating something. So if I hit second trace, look at these two. Which one of these two do I want right now? Maximum. Now, it's going to ask you 3 questions. What is your name? What is your favorite color? No, it's going to say, maybe some of you guys get it. Left bound, right bound. Yes, it's going to ask you those 3 questions. It wants to give you, it wants it to give, you to give it an area to search it. So right there is the answer, correct? So it wants a left bound and a right bound, and then a guess. So it knows where to search, because how much of this graph exists? From negative infinity to infinity. I want to let it know, just search here. Yes? So it wants a left bound. So here's what I normally tell students to do. Put your cursor on the answer, hit the left arrow a few times. Enter. Now I'm definitely to the left of the answer. Put the cursor on the answer again, hit the right arrow a few times. Enter. Now I've given it an area to search in. Now I give it a good guess. I try to put the cursor on the maximum, enter. And then it tells me the maximum value is this, and that occurs at this. Yes, ma'am.
Can you go back and kind of test this step?
Yes.
So wait,
Where you have the Y1 on the top, or like left bound being.
Sure, I'll get there.
so on the test you'd write parentheses 0.88 comma 1.05.
What would you write if it said what is the maximum value? What would you write?
You should.
Sorry? But what's the answer? What's the answer? Do it again?
0.884.
No. That's where the maximum value happens. What is the maximum value?
So 1.05.
This. Value means output. So when you say what's the maximum value, it's saying what's the maximum output. Where does that happen is what input causes that. So if I said what is the maximum value, I need that number. You could say this occurs at this, that's fine. If I say where does the max occur, you better tell me x equal 0.88, blah, blah, blah.
Okay, so where is the
Where's the x? What is the y? I don't know. Third base. All right, so let me do that again. Hit second calc maximum. And you can actually just hit the number 4. You don't have to scroll down to it. See how I'm on the answer, basically? So get your cursor to the answer and then hit the left arrow a few times so you know you're to the left of it. Put your cursor on the answer, hit the right arrow a few times so you know you're to the right of it. And then put your cursor back on the answer. Okay. It is possible that if you're sitting next to somebody, you guys could get slightly different answers because the calculator uses an algorithm to get to the answer, and it depends on how much you zoomed and so it could have little changes in how it's not going to be, it might be different like at the end of the decimal. And what's really neat is if you go far enough in math, you actually learn the algorithms that the calculator is using. So if you're like, I don't need to know that, great. Okay, don't go there. How are y'all doing? By the way, all of this is on that TI guide that's up in Canvas. I'm not telling you you can't ask me questions. I'm just reminding you have another place to go if you're by yourself. There's a guide in Canvas that tells you everything you have to do with the calculator, including this. Yes? Are you good? Okay. You're just showing me your pen. I like it. How are we doing so far? Is that all right? And then I want to get back into any other questions. I'm going to talk about end behavior specifically for a minute, and then we're going to do some general examples from like what we did yesterday. Any other questions before I do that?
Actually, final question. On when you put the negative square root of x, and then you graphed it, but you said that it was going to affect the y-axis since it's negative on the outside.
Outside, up and down. Yes.
How would the graph look if it was inside?
Like this.
Oh, so x.
Inside, left and right. Outside, up and down. It's almost too good to believe. Does anyone feel that way or no? You're all like, none of this is too good to believe. What are you talking about? But this is so beautiful. It doesn't matter what the shit. If it's inside, it's left and right. Right? So this is why it shifted left to right. Outside, up and down. That's why it shifted up and down. Okay, maybe. Maybe? Okay. And, I just want to say this. This isn't easy. I understand this is not easy. It isn't. And I never mean to imply that it should be easy. I'm just trying to show you it's not as bad as people often think. There are reasons that it makes sense. You don't just have to memorize what the shit I do and do it. That never makes any sense. If you don't understand why you're doing something, ask. Come see me. Yes? Okay. Anything else before I get back into stuff? Okay. So let's do this. I didn't really do this, and I want to make sure we're all cool with this. Can somebody tell me roughly what this would look like? Yeah. What's really neat, the higher, this is just a little side note, the higher the power gets, here, I'll show you. This is just an interesting side note, so it almost doesn't matter, but I can't seem to stop myself. If I put in here x squared, you get your nice little parabola. Oh shit. And you're all like, sure, Jeff. Maybe share with the class, I'm sorry. Alright, if I put in here x to the 10th, I'm going to get a parabola still, but can anyone tell me what is... Let's see if that's a high enough power. Oh god, that's a little too high, okay. Does that look a little different? Yeah. What? Now why does it make sense? Okay, real quick.
Can you move the calculator just a little?
Move it? How do you mean?
Just so I can see the number, right, please? Okay.
Is that good? Okay. Real quick. What is 2 squared? 4. What is 2 to the 10th power?
A really big number.
Really big number. I think it's 1,024, but don't hold me to that. You guys, so the minute you get in here above 1, this thing is going to shoot up crazy. Now, real quick, does anyone know what 0.7 squared is? Yes, you do. What's 7 times 7? So what do you think 0.7 times 0.7 is?
0.49?
0.49. Did it get bigger or smaller when I squared it?
Smaller.
The only numbers that get smaller when you square it is between -1 and 1. Or really between 0 and 1. You guys with me at all? Do you see how this in between 0 and 1, if I zoom in on it, why am I spending so much time on this? Because it's neat. I'm sorry. It's not going to affect anything you do. But if I zoom in on this is where things are weird. There's a nice parabola. And then here comes, hey! Now you can see the little twist to it, yes? Further out, it looked like it was just bam, bam, bam. But, 0.5 squared is 0.25. 0.5 to the 10th power? Holy shit. That is roughly, if I'm doing it, 0.001, I think, around there. So how high up does it get at 0.5? Now, that's why it looks like it stays really low, and then it goes, and then once it hit 1 to the 10th is 1, and then 2 to the 10th, forget about it, so it just goes crazy. Are you guys all right? No, I'm sorry, I went way too deep there. The important thing is, if it's an even power, does everybody agree it's going to have this shape to it? The bottom just gets flatter if you might get a really high power. But they all have this end behavior. At the ends, it does this. What about an odd power? This. Yes? I think that's right from your perspective. Yes. You guys all with me? Okay. Okay, good. So if I have a function like this, negative x to the 8th minus 7x to the 7th plus 6x to the 4th minus 2x plus 1. Yup! It's always a little creepy when I say yup. Too bad. What is the degree of this? What's the highest power that you see? That's all a degree means. 8th degree. When x gets really, really freaking big. I really want you guys to understand. When x gets really big, that is really big. If x is 18 billion, isn't that big? But compared to this guy, that ain't shit. Do you understand? So relatively, when x gets really big, all of these are basically nothing. Do you understand? You with me? I need you guys with me. So when x gets really big, which term dominates? The first one. So when x gets really big, what should the graph look like? It should become the graph of this.
So probably.
Only this. So can anyone tell me that piece, what would it look like?
Looking upside down.
Good. And not this, but that, because it's negative. It's been flipped. I love it. I like how all you guys are doing this. Like you're saying, bring it, Matt, boy. All right. I know I made you do it. I'm sorry. So if I ask you for n behavior, I'm never going to write that, so just get used to ED. Yes? It's just too many writing things. Okay. What I want to see from you when you get a problem like this is say, it goes like negative x to the 8th, and that looks like this on the ends. Why do you only graph the ends? Because what is this thing going to do in the middle? Wobble. Yes? Because when x is small, this shit becomes more important than this shit, so it turns around. So then the middle is controlled by all of these, and it could wobble a bit. I need this to make sense. You guys with me? End behavior just means when x gets really big, what do the outputs do? Now, listen, dear God, just in case you go in for help, you might have somebody, if x gets really big negative, what do the outputs do? If x gets really big negative, what are my outputs doing?
Going down.
The outputs are getting really big negative. If you ever see somebody starting to write the answer like this, say, that's great, man, that's great, but my teacher just needs this. And if they say, oh, you got Jeff, he's crazy, just go, I know, just help me with this. And then listen, I need you. There's nothing wrong. Do you guys understand how this says the same thing this does? This is just unnecessarily technical. We are going to use that kind of notation later when it makes more sense. With this shit, I just need what does it look like at the ends and why. That's all I need to see. Ain't no reason for being this technical. Not yet. Okay, you guys with me? So they're not wrong when they say it. I just think it's adding complexity when we're not quite ready for that shit yet. Let's just focus on the idea. Okay.
If it was negative x to the 7th and odd number and it goes like line, would you put the arrow to the left side or the right side?
All right, let's do problem A. So if I had this, I'll be really careful. What's the end behavior? What's it gonna be like? It'd be cool when I write this little thing. It's gonna go like what?
Negative 5x to the 7th.
Because that's the highest power, yes? So be careful, people, putting it in different orders. Now, normally, what does an x to odd power look like? And what's going to happen now? It's going to switch. Yeah. It's going to reflect, correct? Yes.
Why did you take out the 5?
Oh, because the 5 doesn't care about the shape. I need you to see that. 5 just makes it go up higher or lower. It doesn't actually change the shape. I don't care about the 5 if I'm just talking about end behavior. If I have x to the 4th, what's the end behavior? X to the 4th. You ready? Can everybody do it? Can everybody do it? X to the 4th, what's the end behavior? All right, what is 5x to the 4th? What's the end behavior? Did you have to move it all? Okay, good. You see? So a multiplier is just going to change how quickly it goes up, and I'm not getting that kind of detail. I just need to know what's it doing at the ends. So at the ends, this thing is doing this. Is that cool? Because x to the odd looks like this at the ends. So x to the negative x to the odd should just reflect. Okay, how are we doing so far? So that's end behavior. End behavior kicks a lot of ass. I'm going to show you again why. Okay. So I want to do one example with you. And then I'm going to let you guys work on a worksheet together. And I want to point out, I'm gonna give you a function. That would help, Jeff. Yeah, I know. Okay. Now, in general, the way you should look at this as somebody's already done a lot of work. What work did somebody do for you? They factored it. So therefore, what's in your future? No? What's in your future? I'm going to give this to you unfactored, and you're going to have to factor it. At this very moment, if I gave this one to you unfactored, well, actually, this one, no. Maybe. If I give you these unfactored, there's a lot of them we cannot factor currently. You don't know enough yet. Maybe you do. Maybe some of you guys have done synthetic division before. I don't know if you've done that before. I'm going to show you a tool, and if you've seen it before and you hate it, I'm going to try to get you to love it because it kicks so much ass. So first thing I want to ask you guys, can anyone see, and this is a skill in itself, never multiply this shit out, but if you did, what would the highest power be, and is it positive or negative?
X to the third is positive.
Careful, it's not x to the third.
Negative x to the
Yes, negative x to the fourth. I need you to be with me. If I just look at this piece, if I FOIL that, what's the highest power?
x squared.
Squared times this,
X to the third.
x to the third, plus other shit, but I just care about the highest, times this,
X to the
x to the fourth. 1, 2, 3, 4. That's simple to tell how big the degree is. Never multiply that shit out. There's no purpose. Do you guys see that? I'm literally just adding powers. 1, 2, 3, 4. That's collecting all the biggest x's and putting them together, which is what I would do if I'd FOIL this sucker up. So this goes like what now?
Negative.
X to the
Negative x to the 4. So what's the end behavior? Down, down. Can you stop for a minute? It would be an upside down parabola, yes? So I definitely did not have to graph it. In fact, you need to be able to get this answer without graph. If you graph it, you just look and go, oh, it's going down. No, I don't care. I need you to be able to see that yourself. Yes? Now, that's what we've been talking about. Can anyone just tell me the x-intercepts?
0, 0.
Good. So the x-intercepts. I could also call these roots, which is what I normally call them, but we'll see. 0, 0 from this guy, yes. What else?
3, 0.
3, 0. What else?
Negative 1, 0.
Negative 1, 0. If it's factored, yay. We're actually doing good. I always feel a little rushed because, I mean, I don't know if you've noticed, but pre-calc has a lot of concepts. We're almost caught back up to where we're supposed to be, even though the last test we stopped 3 sections short. So I'm gonna split it.
And then the y-intercept is 0. Right?
Oh, sure. Here, we'll do the y-intercept on the, yeah. The funny thing is, anytime one of your x-intercepts is this, the y-intercept is this.
Okay.
How many y-intercepts can you have?
1.
1. So the minute something is 0 here, that's the y-intercept. So if you get 0, 0, that's the y-intercept. Now on one level, that sucks. Because normally the y-intercept is one more piece of information, and the y-intercept didn't give me any more information. Damn it. So yeah, y-intercept is also 0, 0. What am I going to do right now, though, underneath here? What am I going to investigate about these guys? Anybody remember? He's looking at you. Okay. He's judging you. Huh? I heard it.
Multiplicity.
Multiplicity. Multiplicity. All the multiplicity is how often did we get this answer? How many times did 0 show up as an answer?
1,
How many times did 3 show up as an answer?
2.
Twice. And how many times did negative 1 show up as an answer?
1.
Now, real quick, what was the highest degree again on this polynomial?
X to the
4. How many answers must I get then?
4.
4. And did we get 4 answers? It looks like no, but yeah, we did. We got 0, we got 3, we got 3, we got negative 1. We got 4 answers. So this showed up once, this showed up twice, this showed up once. I love you guys. gotta stop saying that because people don't believe me when I say it. Alright. This is tricky. What does it mean to have an odd multiplicity? Like I have two of these with an odd multiplicity. What's it gonna do?
Goes through.
Careful. What bounces? What turns?
Even.
Next to the what power?
Even?
Even. So if it's even multiplicity, it's gonna bounce, like a parabola would. If it's odd multiplicity, it's gonna go through like a cubic would. That's exactly why it acts the way it does. And let me get even deeper down with you guys. I'm gonna overanalyze this for a minute. I'm like, isn't that what you always do, Jeff? Okay. Just we don't have to do this, but I want to show you. Does everybody agree that this, if I put a 3 in, the whole thing is 0? Yes? If I put a 3 in, the whole thing is 0. That's how we get the x-intercept of 3. So what is f of 3 is 0. What is f of 2? That would be,
Negative.
just go with me for a second. Negative 4,
Negative 1 squared.
negative 1 squared, 3, yes? Negative 1 squared is 1 times 3 is 3 times negative 4 is negative 12. Is that cool? What is f of 4? Negative 8 times 1 squared times 5. That would be negative 40. Is that cool? Did the sign change on either side of 3? Did the sign change? No. So that's why it turns. It does. If it goes through the x-axis, what happens to the outputs? If it's down here and then it goes through the x-axis, they were negative and now they're positive. If it turns, the outputs stay the same sign. So here, so around 3, if I'm on one side or the other, the outputs stayed the same sign, didn't they? So what do you think is going to happen around like negative 1? F of negative 1 is 0. What's f of negative 2? It would be 4 times negative 5 squared times negative 1. That is negative, yes? Negative 100. What's f of, I gotta be careful because I don't want to use 0. Oh shit, what is f of negative 1/2? Well, that's gonna be gross, but I don't care about the number. Let me see if you guys are with me still. This would be negative 2 times negative 1/2 times negative 1/2 minus 3 squared times negative 1/2 plus 1. Let me see if you guys are all with me. What sign is this?
Positive.
Positive. Whatever number this is, what sign is it going to be at the end? Because I square it, yes? And what sign is this?
Negative.
Negative 1/2 plus 1. So what's the end answer going to be?
Positive.
It was negative, and now it's positive. Did it go through the x-axis? Yes! So if I have a squared piece, it doesn't change sign on either side, so like in this case 3. It stays the same sign, so the overall function does not change sign. That's why it bounces. If I have an odd power, it changes sign. That's why the function goes through. Okay, maybe. If you don't like any of that, just memorize. Odd power, through. Even power, bounce or touch, whatever you want to call it. Or turn, sorry. How are we doing so far? Did I go too far? Yes.
Do we have to write that for writing multiplicity?
Yeah, I'm going to ask you, you'll see on the handout, I'll ask you the roots, the multiplicities, and the behavior at the roots. When I say behavior at the roots, does it turn or does it bounce or go through? Yeah. Okay. All right, so if I want to graph this thing, oh, yeah, I got that. We're going to need some help. So I got 0, 0. It looks like all my x stuff are nice numbers. I'm going to use a scale of 1 on my x-axis. So I got an intercept 0, 0, I got an intercept negative 1, 0, and I got an intercept 3, 0. My y-intercept is 0, 0. That kind of sucks. Ooh, that is a good reason to do that. We'll be okay. So let me ask you this. All right. Where do I start graphing this? Where do I start? Do I start up here or do I start down here? Yeah, why?
Because it's negative.
End behavior tells me, yes? So I would start, I'm not going to start graphing it. I would start, and then what am I going to do at -1?
Go through.
Go through. The only one I'm going to bounce at is at 3, yes? I'm going to put a little b next to him. So I'm going to go through both of these. Is that cool? So I'm not graphing it. I would go through, and then somewhere I've got to turn and get back down here, yes? Now, in this case, you could plug a -1/2 in and see how far up it goes, but I almost don't care. It can't go that far up because I got to get back down pretty quickly. But what's a really good number to know? Because what am I going to do after this? I'm going to go through, and at some point I have to turn and come back up. So do you see how it's really good to know how deep this goes? There's two options here. What number do you want to plug in?
1.5.
Yeah, you could plug 1.5, but to be able to do this quickly, you could plug a 1 or a 2 in. So I'm going to plug a 1 in, just because. So what's f of 1? Let's see, -2 times -2 squared times, what am I doing again? 2, a whole bunch of 2's. So that would be 16, -16, I believe. So if I make this scale, 4, 8, 12, holy shit, 16.
I think you plugged in 1 too.
Did I put the wrong thing in? What did I say, 1?
You plugged in 1.
-2, -2, 2. Sorry?
Well, I guess you said 1? Right.
Yeah, I plugged in 1. Sorry. Is that cool?
You just
Okay. So this will be -16. Okay, so now I would start down here according to end behavior. I would come through here. If I wanted to, I could figure out how tall it goes, but it almost doesn't matter. It doesn't really have a lot of time. Then I would come down through here, and it kind of makes sense that I go a little bit deeper, but you know, and then I would go, I should be more curved. Make that big. There we go. Okay. I shouldn't look at the screen when I'm graphing. Oh, bounce. That's why I put the little B there. I love you guys. Look how quickly you're all like, Jeff, what the shit, man. Now, real quick. That almost would have been good. I could have almost pretended like I did it on purpose. What I was about to do is say, let's check end behavior. What's our end behavior supposed to be? Down on both sides. So if I had done that and said, I would have noticed right now, oh shit, I made a mistake. I forgot to bounce there. Yes? So end behavior gets you started, and it makes sure you end up in the right place. Now this is not a pretty graph. You agree? For so many reasons. But it shows what it needs to show. That's what I want to see. I almost do not want it too perfect, because then I know you just copied it. You with me? I don't want to know how deep that goes, because if you do, you got more information than you should have. I want this to be not good in some ways. It's good enough though. Okay, maybe. I appreciate you guys. You're all like, that was perfect. Okay. All right, so let me give you this. So I want you to start working by yourselves, and then I'll try to put you in groups.
Fine, you need to double the roots.
Do it again.
And I'll tell you exactly what you apply for like what you need for your maze.
I'm doing that.
That's what you're not supposed to use anyway.
Yeah.
Yeah.
All right, guys.
Okay, that way you don't.
Interest of time, let's do this thing.
Here's like how to set it up.
It's like, look at the X here.
Yeah, because it's like we're making
That's
the
your-
X 0 between 1 and Y.
So what's the highest power for this guy?
X to the fifth.
And it's positive, so it's going to go like this. This is exactly all I need to see for end behavior. What it looks like and why.
So you You guys got 0, 0.
Intercepts.
2, 0, and then negative.
Yeah.
Yeah, 2, 0, negative 1, 0, and then what's my y-intercept?
Negative 8. Yeah.
Okay. How we all doing out there? Okay? Pretty much went around everybody. We all got this one okay. Multiplicity. This has got a multiplicity of
3,
3. This one's got a multiplicity of
2,
2. So this one it's going to
go through.
through, and this one is going to bounce. And that's why, yeah, again, if you see me say root, that means x-intercept. It's just a smaller word, there's less typing. Less writing. Okay, so now I can plot my intercepts. My intercepts have nice numbers for my x-intercepts. So I'm going to go by ones here. I don't know what to do with my y-axis yet. So I got 2, 0, negative 1, 0. I know I have a 0, negative 8 y-intercept, but I don't know what to do with that yet. Can you guys see? The only thing I'm not sure about is at 1. Yes? So if I figure out what f of 1 is, yeah, then you'll get 4 times negative 1 is negative 4. So I know it's, so now I can make my scale for my y-axis is not too bad. I just got to make all the way down to negative 8. So I'm going to go by 2's. So then I know f of 1 is negative 4. I've got my y-intercept. And my end behavior tells me how to start. So I start here. I'm going to bounce at negative 1, which is good because I got to get back down here for my intercept. Then I'm going to turn around and go up through here. It gets a little bit wonky here. And then I'm going to go through 2. And thank God because that matches up with my end behavior. Okay. How are we doing there? Is that? I think I went around to everybody. We all pretty much got that. Okay. This one is going to be a little more crucial to figure out the values of other function values. What do you guys get for the end behavior here? X to the 5th. I love it. I see you over there. It's positive. I should have made it negative, but too bad I didn't. Intercepts. What are the x-intercepts?
2, 0.
Yeah, 0, 0. 4, 0. Negative 2, 0. What's the y-intercept?
0,
0, 0. The behavior, so what's the multiplicity at 0? Yeah, so it's 2, so it bounces. 4, 0. 2, so it bounces. And negative 2, 0.
1, 2.
So it goes through. Okay. So, again, my x-intercepts all look good for a scale of 1. So I know my x-axis I can make a scale of 1. 0, 0, 4, 0, and negative 2, 0. Then I know my y-intercept is 0, 0. That kind of sucks. So I know I'm going to start below. I know I'm going to come, and I'm going to go, where to go through? I'm going to go through this one, and everybody else I'm going to bounce. I'm going to go through this one. I'd love to know how high I go. Sorry? Is everybody all right?
25.
Do it again? Sorry.
25.
Okay, we'll get there. So I'm going to come up. I'd love to know how far up I'm going to go. And then at some point I'm going to turn. I'm going to bounce. I'd love to know how far up I'm going to go. And then I'm going to turn, and then I'm going to bounce. So do you see what I just did was I figured out, I don't know the y scale yet, because I don't know any outputs yet. But I just identified inputs that I'd love to know the outputs. I'd love to know what f of negative 1 is, and you're telling me it's 25. That sounds familiar. And I'd love to know what f of 1 is, for example. 27? Cool. So now I know what my y scale probably should be. I'm going to go by, what are you going to go by, math boy? I'm going to go by 6s. Why not? So I got negative 1 is 25, and 1 is 27. So now, I start down here, I go through the first dude, and every other one I'm gonna bounce. So I go here, I'm gonna bounce down here, go up here. It probably goes up higher, but it doesn't matter. And I'm gonna jump down, and I'm gonna bounce. Does it match up with my end behavior? Yes, thank the gods. Is everybody semi with me? How we doing? Is that okay? Does that graph look freaky? Hell yeah, especially the way I did it. Good lord, I'm all over the place. You could have used f of 2, and I have a feeling that f of 2 is probably bigger. Did anybody else do f of 2? 64, yeah, so it goes way up. But I didn't get that information. I don't want to see that information if you didn't get it. So, but if you did f of 2, your y scale has to be different. Yeah. Okay. So this graph is admittedly wrong, but it is right. It's as right as it can be based on the data we collected, and that's the whole point: is can you graph something based on what you see? I don't care about it being perfect. Okay. So one little thing, getting us into the next idea. Do you guys remember? Are you going to be really excited? You ready? Do you guys remember how to do that long division? I love that reaction. I want somebody to go, Jeff, we're in algebra.
You like put a thing to the side with like something to multiply by. Like so I would multiply it by like 10, get 710 and then minus 710 from it or something like that.
That's too big. That is interesting because I teach math for elementary teachers, and that's a scaffolding of where you just kind of do repeated subtractions. But we can be a little more straightforward with this. Does anyone remember how to do this?
Yeah, is it?
Do I look at 71? No, I look at 7.
Yeah.
And I look at 43. 7 times what is roughly 43?
6.
6. Then I multiply 6 not just by 7, but by 1 also. Then I change the sign or subtract. Yes? And then I get 9, and then I bring a 9 down. 7 goes into 9. Once, 71, 18, 28, Jeff. Good job, buddy. And then that would be, don't put big ass R, of course. This would be plus 28 over 71. Being silly humans, we write that like this. Does that sound familiar to anybody?
I haven't done this since 5th grade.
I know. But guess what we're doing? We're not doing long division of numbers. No.
Variables?
We're doing long division of polynomials. So here's the faces I see. You ready? I see this face. I don't blame you. But all right. Was this hard? Is this hard? You haven't done it in a while. I don't care. Is it hard? No. Okay. Every single thing we did here has to work the same way here, because what are these? What are these? No, what are they?
Numbers?
They're numbers. They have to act like any other freaking number. So watch this. Watch. Don't worry. We'll do more of these next time, but I just want to lay down this idea. You ready? How did I do this? Did I look at the whole 71? No, I looked at 7 and I looked at 43. All right. X times what is x squared?
X.
Holy shit. X times x, x squared. X times 2,
2x.
2x. Then what did I do?
You subtracted.
That's right, I changed the sign. So I changed the sign. These cancel, yes? What's 4x minus 2x?
2x.
And then I,
Plus 6.
do you see how every step we're doing is the same thing we did before? X times what is 2x?
X.
X times what is 2x? X times what is 2x?
2.
2. 2 times x is 2x. 2 times 2 is 4. And then I
Cancel them out.
change the signs. 6 minus 4 is
2.
2. So this would be plus 2 over x plus 2. Every step we did was exactly the same step we did with numbers. Now, real quick, does that look as nice? No. Was a long division already kind of like, oh shit? But again, you just forgot, it's not hard. I understand this looks weird, I understand, but if you can see, we did every step exactly the same as we did with the numbers. This is so exciting, because yay. Okay. So we're gonna do more of this, and I'm gonna show you a shortcut for this kind of problem specifically. There's a shortcut. Yay! Alright, I'll see y'all tomorrow. What else is happening tomorrow? Quiz.